How is my favorite class today? Today we're looking at my kitchen sink. And today we're going to talk about the Coriolis effect. This guy a long time ago, this Frenchman, Gustave Gaspard de Coriolis, in 1844, he did a bunch of math and he got the credit for what's called or what's termed the Coriolis effect. The Coriolis effect is the apparent deflection in fluids, fluids being air, fluids being water, the apparent deflection of fluids on our planet Earth. Now let's have a look. I'll pull the plug and we'll get to see it firsthand. See the whirlpool starting? I can just start to see a whirlpool, and that whirlpool is spinning in a clockwise manner. Now why is it spinning in a clockwise manner? Because we're in the northern hemisphere, boys and girls. Now I'm going to show you exactly why when we go over here. This is a representation of our planet. This is a globe. And on our globe, you will see that right here where we live, Cape Breton Island, is on the Atlantic Ocean. And on the Atlantic Ocean, currents in the Atlantic Ocean turn this way. In the South Atlantic and the Southern Atlantic Ocean, they turn the opposite way. They turn counterclockwise. So why is this? Also, air, atmospheric air, which we'll represent by showing you this thin piece of saran wrap. That's about the thickness of the atmosphere in actuality covering our planet. It's very, very thin. Our atmosphere also has current patterns that we're going to discuss at a little later date. And that's because of, as we've said, the Coriolis effect. Gustave Gaspard de Coriolis, 1844, he did the math, he got the credit. It's because of the deflection of fluids caused by the rotation of our planet. And this is the way our planet rotates. So he did the math. What math? How fast is our planet rotating? How fast does it have to rotate to cause these currents? Well, it's pretty simple. How do we measure? How do we measure speed? We measure speed in kilometers per hour. Are we all in agreement? Kilometers per hour. So let's measure the speed of the Earth. Well, how many kilometers is the Earth at the equator? It's about 40,070. And if we divide that by how many hours in a day? 24. So what does that equal? 40,070 divided by 24, it equals about 1,670 kilometers per hour. That's how fast our planet is spinning at the equator. Why don't we notice that? Well, we don't notice it because we're born into it. Like a fish born into water, the fish doesn't recognize the water around it. And like us, we are born into this, so we have adapted to this, in addition to the really strong gravitational pull of our planet. Hope you learned something here today, boys and girls. Just to revamp what we talked about. Gustave Gaspard de Coriolis in 1844, he did the math, he got the credit for the Coriolis effect. The Coriolis effect is the apparent deflection in fluids caused by the rotational spin of our planet. Have a great day, boys and girls.